Hi there, Mr. Sutton here, bringing you the AB Calculus 510 Extra Practice #1 solutions on FTC integral evaluation with polynomials. For this one, we're trying to evaluate this definite integral. So let's start by taking the antiderivative of the integrand here. So that's going to be, let's see, using our reverse power rule, this is going to be 1/2 x squared plus 2x, all of that evaluated from -3 to 1. So we have all of this stuff with 1 plugged in, minus all of this stuff with -3 plugged in. And over here on the left side, let's see here, this is 1/2 plus 2. That's 1/2 plus 4/2 essentially, so 5/2. And over here, let's see, this is 9/2 minus 6. Well, that's 9/2 minus 12/2. That's going to be -3/2, but we're already subtracting this. So minus minus gives us a plus 3/2. 5/2 plus 3/2 if you want to simplify it. This comes out to 8/2 or just simply 4. For this problem, I want to evaluate this definite integral. So I'll start by taking the antiderivative. That's going to be, let's see, using our reverse power rule, this bumps up to a 2. Dividing by that, we have x squared. And then the reverse line rule here gives us plus x, evaluated from 0 to 3. So we've got all of this with 3 plugged in, minus all of this with 0 plugged in. Well, this 0 bunch of stuff is just 0. So really, we just have 9 plus 3 over here, which comes out to 12. To evaluate this integral, we're going to first take the antiderivative. So let's see here. Using our reverse power rule, this bumps up to an exponent of 3. Dividing by that, we have -1/3 x cubed. And then for this one, we have an x squared. Dividing by 2, that's going to be a -4. So -4x squared. And then this will be minus 12x. So evaluating that from -6 to -1, we have all of this stuff with -1 plugged in, minus all of this stuff with -6 plugged in. And we're just going to go left to right and simplify this. You don't really have to simplify it. I mean, this is numerically equivalent to whatever the answer is. But I like to practice it just for multiple choice questions. So right here, this is -1/3 times -1, so that's a positive 1/3. Here we've got -4 times 1, so just minus 4. This is going to be plus 12, and then we're negating everything in this second bracket here. So let's see here. This is -6 cubed. That's going to be -216. I don't know what that divided by 3 is, so let me think about this another way. This would really be like 36 times 2. Because we take a third of one of those 6's. So that'd be 72. Now, in terms of the sign of this thing, we have 3 negatives here, another negative, and another negative. Odd number of negatives gives us -72 when the dust settles on that one. Over here now, this is going to be 36 times 4. Negative gives us a positive. That's going to be positive 144. And then over here, this would normally be positive 72, but we're subtracting everything, so this is a -72. All right, so I've got a 1/3 and a whole bunch of non-fractions. Let me add all the non-fractions together. Let me do them in an easy order, because I happen to notice we've got a -72 and another -72. Together, those are going to cancel out the 144. We have a -4 and a plus 12. That's going to be 8. So this really just comes out to 1/3 plus 8. Which is 1/3 plus 24/3, or 25/3. To evaluate this integral, let's first take the antiderivative. So using our reverse power rule, because this is a polynomial, we have, let's see, a coefficient of 1/2 here. The exponent's going to bump up to a 3. So we have 1/2 times 1/3, or 1/6 x to the third. Next, this bumps up to a 2 for the exponent. Dividing by that, this is just going to be minus 1x squared, and then we'll have a minus 3x. So we're evaluating all of this from 0 to 5. So that means we have all of this stuff with 5 plugged in, minus all of this stuff with 0 plugged in. Now the nice thing about this is all these terms with 0 are just going to go away. So really it's just this first bracket of stuff, if you wanted to simplify this, that you're going to have to deal with. So this is 125/6. Minus 25 minus 15. So that's 125/6 minus 40. Well, 40 is really going to be 240/6, and we're subtracting that. So let's see, this is going to be negative 115 over 6. And I don't think that can be reduced, so not that we needed to simplify. Anyway, we're just calling it done here. To find this integral, we'll start by taking the antiderivative. So that's going to be, let's see, this bumps up to a 4, so this is going to be negative 1/4 x to the 4th, plus this exponent bumps up to a 3, so that's going to be 4/3 dividing by that new exponent, 4/3 x to the 3rd, minus 2x. Evaluating that from 0 to 4, we're going to plug 4 into all of this stuff. And then from that, we're going to subtract all of this stuff with 0 plugged in. Now, on this particular problem, since everything here had a variable, plugging in 0 pretty much wipes out that whole second bracket. So really, it's just this first bracket that we're looking at. So going through term by term, we've got 4 to the 4th. Actually, one of these 4s can cancel with the 4 down here. So this is really negative 4 cubed, or negative 64. Next, we've got, let's see here, 64 times another 4 is 256 over 3. And then finally, this is minus 8. So this is negative 72 plus 256 over 3. How many thirds is 72? Well, let's see, 3 times 72, that's going to be, well, let's see, 3 times 70 is 210 with another 2, so 216. This is negative 216 thirds. Adding that to 256 thirds, we have 40 thirds. To evaluate this integral, we have to first take the antiderivative. So using our reverse power rule, this first exponent is going to bump up to a 4. Dividing by that, we have 1/4 x to the 4th, minus this one bumps up to a 3, so this is going to be 1/3 x to the 3rd, minus, we've got a 3x there. All of this evaluated from 1 to 2. So I've got all of this stuff with 2 plugged in, minus all of this stuff with 1 plugged in. And you don't need to simplify any further, but if you did, here's what would happen. So just going through term by term, we've got 1/4 times 16, which is just 4, minus, let's see, this is a third of 8, and then we have minus 6. Over here, this is going to be minus a 4th, distributing this negative at the same time as I do everything else here, and we're going to have plus a 3rd, and then finally this is going to be plus 3. So let me combine my constants and my like terms, at least my common denominators, and then I'll go from there. So I've got a 4 minus a 6 is negative 2, plus a 3 gives me 1 for the non-fractions. We have a negative 8 thirds and a positive 1/3. That's negative 7 thirds. And this negative 1/4 is just kind of the singleton floating there. Now let's combine these. Common denominator is going to be 12. So I have 12 twelfths minus, let's see here, this is going to be 28 twelfths. That's negative 16 twelfths. Minus another 3 twelfths is going to be negative 19 twelfths if we have to go all the way there. To figure out this integral, we're going to start by taking the antiderivative with the reverse power rule. So going from left to right, first exponent bumps up to a 6. Dividing by that, we have negative 1 over 6. After that, the exponent is going to become a 4, so that's 3 over 4, x to the 4th. And then this will be, let's see, exponent of 2. Dividing by 2, this is negative 1x squared. Finally, we have a minus 3x. So we're going from 0 to 1 with this. Let's start by plugging 1 into all of this stuff. And then we're also going to plug in 0 and subtract everything there. Now the good news is plugging in 0 is going to zero out everything in that second bracket. So it's really just this first bracket. And we just have 1 plugged into everything. So we just have negative 1/6 plus 3/4 minus 1 minus 3. Nothing fancy going on there. So that's minus 1 minus 3 gives us a negative 4. And let me just get a common denominator so I can add all this together. So I've got, let's see, 12 would be a good one to use. So this is negative 2 twelfths plus 9 twelfths minus 48 twelfths. We have a negative 50 over 12 plus a 9, so that's a negative 41 twelfths when all is said and done. For this free response problem, we've got this cubic polynomial with some a's and b's and k's that we're going to have to find at some point. And let's see here. We have a local min at x equals negative 1, point of inflection at x equals negative 2. All right, so what can we do with this? We want to find a and b. That's our first task on this. So to figure out a and b, The key here is that they told you the location of a local min and also a point of inflection. Since we know that we have a local min at x equals -1, that means that if I plug -1 into the first derivative of this thing, I should get back a value of 0. So let's find the first derivative, plug in -1, and set it equal to 0 and see what happens. So if I do that now, first derivative, that's going to be 12x squared, plus this is going to be 2ax, so we're just using the power rule, plus b, because b is a constant, and that k gets zeroed out. So the nice thing about this is taking this first derivative got rid of this k, so that's one less thing to deal with. Now if we plug in -1 for x to this first derivative, as I said, we should end up with a value of 0 for all that. All right, well that's not quite enough. I mean, we can simplify this to 12 minus 2a plus b equals 0, but clearly we still have two variables, so we're going to need more information to solve for a and b. So we're going to stop with this branch of reasoning for now. We'll come back to this equation though. At this point, we need to go a little bit further. Now they said that we have a point of inflection at x equals -2. That means if I plug in -2 to the second derivative, I should be able to set that equal to 0. So let me go ahead and take f double prime now. So that's going to be 24x plus 2a, because 2a is one big constant. And then this b just becomes a 0 because b is a constant. So this is another nice thing here with taking this derivative, is we've gotten rid of yet another unknown. Now that we only have one variable left, well, sort of, after we plug in -2 for x and set this equal to 0, now we only have one variable left. Now we can solve for a. So this is really -48 plus 2a. If I add the 48 over there and divide by 2, I end up with an a value of 24. Now that I know what the value of a is, I can go back to this equation where we kind of hit a dead end, and I can plug 24 in for a over here. And once I do that, I can now solve for b. So this is 12 minus 48, so this is going to be -36, which means that for this to equal 0, b must be +36. So there we are, a and b. For this next part of the problem, they are telling us that the integral from 0 to 1 of f of x dx is 32. Based off of this, they want to know the value of k. So this requires you to have done part A correctly, where you found the values of a and b. I'm just taking a quick look back there. In part A, we found that the a value was 24 and b was 36. So now we can actually rewrite the f function. We can rewrite this whole equation as the integral from 0 to 1 of 4x cubed plus 24. Actually, yeah, is it 24? Yes, 24x squared plus 36x plus k dx. All of that equals 32. And at this point, we're just going to use our fundamental theorem to evaluate this integral. Now, we won't actually be able to get it down to a real looking constant because we still have this k value, and our variable of integration is x. So we're going to be plugging things in for x, but that's at least going to get rid of one variable and leave us with just this k value to solve for. But before we can do anything else, we need to take the antiderivative of this. That's part of our FTC evaluation theorem. So using the reverse power rule from left to right, this first exponent is bumping up to a 4. Dividing by that, we have just x to the 4th. Next, this new exponent for the second term is going to be 3. Dividing by that, we now have plus 8x cubed. And after that, this next exponent is becoming a 2. So 36 divided by that is 18, and then we have the x squared. And then just using our reverse line rule, we have plus kx. Evaluated from 0 to 1, all of that, and we still have all that equaling 32. So I've got all of this stuff now with 1 plugged in for x. And then I have all of this stuff, and I'm going to subtract now. I'm subtracting all of this stuff with 0 plugged in for x, and that should all equal 32. Now the good news is all this stuff with zeros is going to zero out, so we can pretty much ignore that second bracket. Over here, we're only multiplying by 1 with a bunch of stuff, so this is going to be relatively easy to simplify. We have 1 plus 8, which is 9, plus 18, which is 27. So we have 27 plus k, and that's all going to equal 32. Well, based off of this, subtracting 27 there, k is going to be 5.